All right, and so now at this point, after you have been briefly introduced to what a rational expression is, let's look at and let's learn how we can simplify a rational expression. Now, I said earlier just now that you have been briefly introduced because at this video lesson level right here, then anyone is quite a beginner to understanding what a rational expression. But believe me, as you continue on further above this course that you're taking right here, you still have a whole world of rational expression to learn. So that's why right now, whatever introduction you have already received, that's just a brief introduction. And as you keep working on rational expression, you will keep building up your skills and your experience. Okay. But so now back to what we're about to learn here. Let's learn how we can simplify a rational expression. All right. So the idea is similar to how we simplify a fraction. So think as closely as you can to simplifying a fraction. So a rational expression is almost identical to a fraction. And so let me bring up a demonstration problem number 1 right here. And this problem here is hopefully just, I put it here as part of the lesson, but hopefully anyone viewing this here can fast forward because you can treat this as a review understanding. All right, so in this problem 1 that I brought up right here, I just want to bring in something that you have seen and hopefully been fluent with. Let's say we have a fraction, 30 out of 130 right here. And sometimes you are asked to simplify it. Okay, this is a more advanced term. Or sometimes you are asked to reduce. This is the term that you probably have been a little more comfortable with. So we want to reduce this fraction, or we want to now, with a more formal term, we want to simplify this fraction. Okay? And so this fraction right here, reducing it, the truth behind the scene, and believe me, anyone viewing this lesson is fluent enough with this so that you can do, you already must have had your answer already. But let me really bring back the fundamentals so that we can use the fundamentals behind the scene so that we can drive into the next lesson. That's why, even though you can skip this, but it's good that you see my steps, see my philosophies a little bit about this. So how it has been that we've been doing the reduction of these fractions. Now 30 as a numerator and 130 as the denominator. So 30, we have learned that's 30 in prime factor as a product of prime factor. 30 is a product of 2 as a prime, times 3 as another prime, times 5 as another prime right here. So 2 times 5 is a 10, times 3 is a 30. So 30, the numerator of our fraction here as prime factors, got 2 and 3 and 5. So I'm going to rewrite that 2 and 3 and 5 here. All right. And the same thing I'm going to do with 130. So 130 here as a product of prime factors. So I've been mentioning it, prime factors. It's going to be 2 times 5 times 13. 13 is a prime number. And these are all prime factors that go into 130. And so now the denominator here being 130, instead of writing 130, I am going to write it as a product of prime factors, of its prime factors. So 2 and 5 and 13. And so now this is where our brain process, our mind process has been flowing fluently for anyone right here. We cancel out, we divide out, or now in a more advanced, as you get more advanced, more commonly people refer to that as canceling out. So we cancel out the common factor. So there's a common factor, 2 and 2 right here. We cancel that away. But really the truth behind the scenes, we divide that factor away. And so that factor is divided away, being gone. We have spotted another common factor over here. So again, we have another cancellation. And so after canceling out these common factors, our successful reduced fraction comes to 3 out of 13. And so like I said, before I arrived this, anyone viewing the lesson should have had this answer long ago. But my point is not about how fast we do it. I just want to remind and reinforce how it has been done throughout all those time you've been doing it so fluently. Because we need these fundamentals to drive into the more important concept we're about to learn. All right, so that's the end of this problem right here that I'm demonstrating. The fraction we have here is a rational expression as well. It's a rational expression. But right now, it's simply taking that as just take that as a fraction, and simplifying a rational expression or simplifying a fraction just basically means the same as reducing it. And so the way how it has been doing, we put each of the numerator and denominator into a product of prime factors. Numerator expressed as product of prime factors. Denominator expressed as product of prime factors. And then we're going to start recognizing common factors from both top and bottom, and we divide those away. Or in a more friendly term, we cancel them away. All right. All right, so after learning from the demonstration problem number 1 right here, let's drive that experience we've had from problem 1 and build that into this problem number 2 right here. So I would like to bring in a demonstration problem number 2 right here. So we are instructed in this problem to simplify this expression here, and this expression now is clearly a rational expression. It's a fraction of 2 polynomial expressions, and it got coefficients from both top and bottom, and it got variables all over. But what we have here is truly a rational expression right here. Okay, not only just a numeric rational number, but it's a rational expression right here. But now we are asked to simplify. And another way of thinking of that, if we keep thinking as closely as we can to the idea about reducing a fraction, then yes, simplifying a rational expression means the same as reducing a fraction. It's analogous, similar, whatever way you want to put it. Okay, and so I'm going to bring in whatever we've learned from that idea of how we reduce that fraction earlier. We're going to bring that idea, that fundamental, into this particular problem right here. So what I've done in the problem 1 earlier is that I have put each of my numerator and denominator into product of prime factors. So in a separate columns right here, we can keep this at scratch level. The numerator for x squared y as a product of prime factors. It's got 4 is, the coefficient 4 can be expressed as a 2 square. So that's a prime factor with a power. Each of the variables here, you've seen that from earlier lessons. Each one of the variables here, now we can see that as its own prime factor. So we got x squared in product with y. So I have just now expressed my for x squared y, the numerator of this rational expression, as a product of prime factors. I'm going to do the same for the denominator. 12xy cubed. I'm writing that as 2 squared times 3 times x times y cubed. So that's how I have expressed my denominator 12xy cubed as a product of prime factors. All right, and so now in that way, and of course, there are viewers for this lesson. There are still viewers who already has had the answer already. But the point is not to be rushing your steps. The point is, I just want to reinforce that idea, that fundamental we've been doing. We recognize common factors, common prime factors from top and bottom, and divide those away. Or in a more friendly term, familiar term, we cancel those away. So that's how we arrive at the simplified or the reduced, the final rational expression. So now this numerator of mine, instead of writing that the way it is, I'm going to write that as the product of the prime factors. So here we're looking at 2 squared times x squared times y. And so now the denominator, 12, the coefficient is written as a 2 squared times 3 times x times y cubed. And now we start recognizing common factors. So the common factor here is a 2, and even including with the square. So the 2 squared and the 2 squares are completely divided away, or now we can say we completely cancel that away. The 3 is not common. 3 is only in the denominator, but it's not in the numerator. So 3 is left here the same. Now there's a x squared and there's an x. So you have to think about it. You have to be careful. X squared means x times x. That's what x squared means. And so as far as common factor, the x, only one x is a common factor. So think about, as a quick little scratch word right here, x squared cancel with x. Really it means x times x, cancel with x. So we cancel the one of the x away with that common factor of x in the denominator. And so that leaves me behind a one leftover factor of x right here. So now, and then the same way with y. Now y cubed here means, see the y over y cubed, it means y, and then there's a y times y times y. And I hope this is the only one. Last time I have to remind anyone about this. And so, as in this expression right here, among the y right here being a recognized common factor, then really just the y, one of the y among the three y's in the denominator. We cancel that away. And so now, after all of those, right, the x cancel with that. In my style, I tend to write that as a leftover factor, and I cancel that with this, but I tend to write that as a y squared, the two leftover factors together. All right, and so now, after all of that has been done, let's collect all of the remaining factors. So the 2 squared got divided away completely. Okay, the x squared on the numerator got divided 1x away, so it's got an x. And then the y's also got canceled away, so now we have just simply x on top. At the denominator, we have the remaining factors here are 3, and together with the y squared. So those remaining factors multiplied together, we're looking at 3y squared in the denominator. And so now, that is how we have arrived at what's so-called a simplified rational expression. So this rational expression here is the simplified. We have arrived at the simplified rational expression. All right, and so we've been up to the second demonstration problem right here, and you've seen the one same fundamental right here. We have to, after we can recognize, after successfully recognizing the product, each of the numerator and the denominator as products of prime factors, then we can just start canceling out the common factors. And that's the ultimate fundamental in terms of simplifying any of the rational expression. And that's what we have observed, and that's what I have been up here on the board reminding everyone about that fundamental. So as far as an observation throughout the two demonstration problems right here, all right, so we arrive at this observation. See, once both numerator and denominator are put in as a product of prime factors, see, or put into product of prime factors, any rational expression can be simplified by simply canceling out the common factors. All right, so that's the observation that we have seen throughout the work I've done with over the two demonstration problems. Okay, so now let's bring that exact fundamental into an actual problem. All right, so in this problem, the third demonstration right here as problem 3, we are instructed to simplify this rational expression. This rational expression is sadly, however, not yet put into product of prime factors for both numerator and denominator. So I have to point out this the critical pitfall right here that a lot of my students tend to fall into, tend to get confused about. Now the 20 cannot be canceled with that 20 because it means really as far as the order of operations. In this rational expressions, 20 must be added, whatever the value for that 5x here, 20 must be added to that 5x before we can divide. And so the same way, the 20 here must be added to the whatever value that come out from x squared plus 9x before we can divide. And so simply speaking, the 20 and the 20 here, they are not common factors. They're just not common factor. Okay? Same way with the x and the x here. These two x's, they look the same. It's the same variable, but they are not common factor. All right? And so view my additional video lessons for how I can explain a little more clearly about how any of these cannot be canceled, or the 20 cannot be canceled here. And then so at the bottom line, the numerator of this rational expression has not yet been put in as a product of prime factors. The same way with the denominator, this denominator has not been put as a product of prime factor. And so in that way, to meet with this requirement, the observation we've made here has naturally turned into a requirement. A rational expression can be simplified by canceling out common factors. So that seems like a method, but it can only be done once both numerator and denominator are put in a product of prime factors. So in that way, in order to achieve that goal right here, we must be able to factor out each of our numerator and denominator. And this is where our skills, our experience we've learned from previous lessons will be brought in and become useful for this particular kind of problem right here. This is where we apply our skill of being able to factor a polynomial expression. So now the numerator. I recognize among the two terms right here, the GCF being 5. So I can factor my numerator as 5 in parentheses x plus 4. And that's how I have completely factored my numerator. So now this factor form of the numerator is understood. And I must have mentioned that in earlier lessons when you have finished learning about factoring. And here it goes again. I can briefly remind that the whole point, think about another way of thinking about the purpose of factoring a polynomial expression is that we trying our best to put a polynomial expression into a product of prime factors. So this is now being regarded as a prime factors of our polynomial, and this x plus 4 is another prime factor of our polynomial expression up there. And so 5 times in parentheses x plus 4. Now we have expressed our 5x plus 20, this polynomial, the numerator, as a product of prime factors. All right. Now x squared plus 9x plus 20, another polynomial expression. Let's bring in our skill from previous lesson about how we can factor out this particular polynomial. So that brings into factor product of x plus 5 times x plus 4. And so again, of course, I don't want to go into the reviewing how we can do this because that's belong to the earlier lessons. So here I'm just assuming that you have already mastered that skill, how you can factor this polynomial into these two prime factors. But so now at this point right here, what we have done now is that we have put our numerator and denominator into products of prime factors. And so now back to that. So now we can start utilizing that observations we have made earlier. And again, once both numerator and denominator are put in products of prime factors, a rational expression can be simplified by canceling out common factors. We have now reached that goal, putting our numerator and denominator into products of prime factors. And so now what we do is just simply recognizing common factors. So I recognize x plus 4 as a common factor. I cancel that away or simply divide that away in formal term. 5 is not common with x plus 5, and 5 here is definitely not common factor with that 5 down here. And so the only remaining, so now we only have 5 as the remaining factor in the numerator, and x plus 5 as one whole factor in the denominator. And this is now how we have simplified our rational expression. So 5 over x plus 5 is understood as our simplified rational expression. The simplified expression of this beginning one. All right. And so I have mentioned that a couple times as I was going through the demonstration problem. So now at this point right here, clearly the terms, as a remark here, when we're saying that we're completely factoring, completely factoring a polynomial, allow me to use some shorthand writing right here, completely factoring a polynomial expression. Okay. So this is one term how we've been commonly saying it. Let's completely factor an expression, completely factor an expression. So completely factoring a polynomial expression, it means the same as putting the polynomial expression in products. Okay? or into product of prime factors. So each factor in the factor form of the complete factored product right here is considered as a prime factor. Okay, so two processes. The wording sounds different, right? The way we say it, the way we refer to it sounds different, but it really means the same process right here. So at the end of your lessons about completely factoring a polynomial expression or a whatever expression right there, that now at this point, to unlock all of that secret, another way of seeing that completely factoring a polynomial expression means you have been putting that polynomial expression into a product of prime factors. And so now after looking at three demonstration problems, especially at after looking at that problem number 3 of the amount of demonstrations, then now we arrive at a solid how-to instruction, how to simplify, right, a rational expression. So in order to simplify a rational expression, the first thing we do, now let's look back at problem 3 on the board right here. See, so a lot of times, and this problem brought us into that kind of most practical situation that a lot of times a rational expression is not already put in products of prime factors. So in that way, the first step, as you have just now seen on the screen, the first step is to be able to put each of the numerator and the denominator in product of primes, or in other way of saying it, in complete factor. And so now, in order to simplify a rational expression, the first step here is to factor the numerator and the denominator completely. Then, after doing so, second step here is to simplify we simplify the rational expression by dividing out the common factors. And this is another way of saying that we are canceling out common factors. So now, again, referring back to the problem we've done. See, first step, I put my numerator and denominator into complete factors. And after that, I canceled out the recognized, or I divided away the recognized common factors. So in here, we only had one common factor. Other problems, we may have multiple common factors. And so that's how we can be doing that. First step, second step. All right. All right, so now we are at example 1 right here. And in this example, let me bring in the solid methods we've learned just now that I put on screen into applying the method into solving this problem so that you can see how direct it is about the method that we've learned. So here we go. In this example, we are instructed to simplify this given rational expression. The variable involved here is the variable a. So the rational expression itself, once again, observation is telling me that neither numerator nor denominator is already completely factored. So first step, the step I put at the corner of my screen right there, first step is to factor out completely numerator and denominator. And so think of that process. For first step, really is there are two independent works right here, and the order of those two numerator and denominator, you have your choice. It's just me. I tend to work from the top down right there, but really those are two independent, separate factoring work. So 3a squared plus 15a, I can factor that into 3a because I recognize a 3a as my GCF among the two terms here. So 3a in product with a plus 5. So the numerator is factored completely into 3a in product with a plus 5 in parentheses. 6a squared plus 6a minus 36 in the denominator. I can factor that as 6 and two pairs of parentheses is a plus 3 and a minus 2. And so now after factoring out completely the numerator and the denominator, and again, this is where you need to bring in your skill how you can completely factor the denominator. So allow me not to bring that in here too far into the explanation of how I factor this denominator into that. But so after successfully putting numerator and denominator into products of prime factors, or completely factor numerator and the denominator. The only common factor I recognize, see the 3 here, think of the 3 here as a just 3 times 1, but the 6 here is a 2 times 3. So really the only common factor we have here is a 3 right there. So we now can cancel out that 3, and the 3 here, after canceling out the 3 in the 6 right here, we left behind with a 2. And so now our simplified rational expression turns into a times a plus 5 over 2 times a plus 3 times a minus 2. All right, and this is our reduced rational expression. And you have your choice to FOIL out the expression here to arrive at the final expression. So you could have also done multiplying a with each one of these terms. We got a squared plus 5a, and then multiplying through all of these, we're looking at 2a squared plus 2a minus 12. So either one of the form here, either one of the two expressions here will be accepted as our final. Any one of these is the simplified expression. All right, and I can put that in a box, or I can also put this in a box. All right, and so as we're working through our skills in terms of, as we're learning through our skills in terms of simplifying a rational expressions, there are quite a few occasions where we recognize factors that are opposites of each other. And opposites, I mean opposite in sign. So let me demonstrate the following idea right here. So as in what it means by opposites. So we can recognize a factor such as b minus a over a minus b. These two, see, the b minus a in the numerator and a minus b, these are, I mean, your eyes right now looking straight at it, they are opposite in the sense that, you know, this one here is b minus a, the other one is a minus b. Okay? So I said earlier about opposites in signs. This is why. So algebraically, b minus a right here, between the two terms, we can factor out purposely. We can factor out purposely a minus sign and leaving it a minus b. Think about if we distribute that minus sign into each one of the two terms right here, we're going to land back into minus a plus b, which is exactly b minus a. And then another way of seeing it, this same expression right here, someone can also argue that b minus a is the same as minus 1. We factor out a minus 1 factor, and then leaving a minus b in parentheses. So minus a minus b, or negative 1 times a minus b, that's the meaning. That's what's equal to b minus a. And that's the reason why now if you're checking out this relationship right here, that's why it points out that b minus a and a minus b, these two are opposites. They are opposite in signs, as I said earlier. In the same way, a minus b, you can think of that as we can purposely factor out the negative signs among the two terms right here, making it minus, and now we have b minus a. Or you can alternatively write that as a negative 1 factor multiplied with b minus a. And this form right here, that I'm putting that in the box right here, is where it says, where it clarifies that b minus a and a minus b are opposite signs of each other again. All right, so now I want to show you some specific cases where we are learning how to simplify a rational expression, but we unfortunately meet some common factors, some factors that are exactly the opposite sign of each other. Okay, so many textbooks tend to explain immediately that, well, something like this. Of course, it makes sense to divide by out and we get a negative 1. Okay, easy to explain because you see, you think of that in what I have explained earlier, you think of that the reason why b minus a over a minus b equals 1 is simply because, see, in what I have explained earlier, b minus a is the same as minus of a minus b, and then divided by a minus b. So in that case right here, now we have clearly the common factor, but canceling out this common factor really, and that's the reason why I really have mentioned earlier that it also means the same, having the negative sign in front of a factor really means the same as -1 as a factor multiplied with a minus b over a minus b. And once we cancel away that common factor, it leaves behind just -1. That's why. Or another way of arguing it, b minus a over a minus b. I also made my argument earlier from the other board that the a minus b here in the denominator is the same as a minus sign times b minus a. And then b minus a on top is, of course, that same common factor. And we think of that here as, we think of that negative sign in front here as a -1 factor multiplied with b minus a. And then there's b minus a here. And then canceling out the common factor. That's how we arrive at -1. And so textbook tends to just take that and write that down as a rule, but I want to give you some in-depth explanation. But fundamentally, I want my students to take this as, see, these are opposites in the sense that I have just proven it. They are opposites because I have made them, I have shown how they are opposite in signs. I have just proven it. So in that way, how I have explained about the meaning of opposites, factors right there, or factors that are opposites. Let's take that experience we have seen in the explanation earlier into an actual example here. So example 2 here, we are instructed to simplify, and the first problem in this example, how about 25 minus x squared over x squared minus 6x plus 5. So what we have here is a rational function, so what we have here is a rational expression. Okay, and so we have already just now spent a lot of time looking at the instruction of how we can simplify a rational expression. So here we go. Let's apply that skill. First step, I am going to completely factor numerator and denominator. So here I recognize a difference of 2 squares. The difference, 25 is a perfect square, 5 square. So 25 minus x squared, I can factor that as 5 minus x times 5 plus x. And 5 plus x is just exactly the same with x plus 5. My denominator here can be factored into, and again, I really have to skip the too much detailed explanation of how I factor these because I want to leave that for my earlier lessons about how you factor any one of these. So anyone arriving at these video lessons right here must already have mastered how you can factor each one of these. And these are, once you have viewed those lessons, these should be within your comfortability. So x squared minus 6x plus 5 can be factored into x minus 5 times x minus 1. So that's how I factor out completely the denominator here. And so now, right at first sight, after completely factored out the numerator and the denominator, I just didn't realize any common factors. But now if we're looking a little closer, I recognize, hey, wait a minute, 5 minus x and x minus 5 are opposites. They are opposite factors. Okay? So now you have your choice. I can purposely treat that 5 minus x. So at this point, it really depends on your comfortability. I am more comfortable with treating that 5 minus x as a minus x minus 5 factor. And then the other factor remains, of course, 5 plus x, or it's the same as x plus 5. And then now in the denominator, it's exactly x minus 5 times x minus 1. All right. And so now we recognize that common factors. That's only common factor. And so we cancel that common factor away. So what about a negative sign right here? So after canceling out away, of course, our simplified expression has that 5 plus x or x plus 5 in the numerator. Okay, and in the denominator, it's x minus 1. And then we can put the minus sign in front right here. Because think about it. Once we have made this expression here to display the negative sign, think about a negative expression divided by a positive expression. The overall expression here is a negative expression. So I put the negative right in the middle. Here it was still the negative of the numerator. But now here it's the negative of the entire expression. So that's how I have arrived at my simplified rational expression. Now, the same work right here, I could have done, so the red ink I'm writing here is just an alternative solution right here, right from that work. I could have decided to keep 5 minus x and 5 plus x in the denominator, in the numerator. But changing that to minus 5 minus x and then x minus 1. And then that would be the same. Now we have a negative expression in the denominator. And then the common factor now is displayed. If anyone viewing the lesson decided to go that way. And then that would arrive exactly at this one here. And we bring that minus sign here to the middle. So either way, it's going to land you into that final simplified expression like that. Right. All right, so in part B of the same example over here, let's look at another rational expression. Now here we're looking at the rational expression here has already had numerator and denominator in complete factor form. So that saves us step 1. That saves us that step where we have to factor completely the numerator and the denominator. So let's just now start looking immediately into looking for common factors and cancel them out. Okay, but now right at first sight we don't really see any common factors. But now looking a little more closely, I recognize, hey, wait a minute, 2 minus x and x minus 2, these two are now opposites. And then further I'm seeing x minus y and y minus x. These two are also another pair of opposites. So we actually got, so my entire intention for bringing in this problem within our example here, so that you get more experience how to handle in case you have multiple pairs of opposites. So here's how I handle it. And so now you have seen my style from problem part B that we've done, part A we've done earlier. I tend to turn the numerator one into the negative that's look corresponding with the denominator here. So 2 minus x here, I'm going to make that a minus x minus 2. And then there's an x minus 2 in the denominator. That's the first step in the procedure. And then x minus y right here is the same with, and then there's an x minus y, then there's x plus 3. So I'll just keep that the same, x minus y, and then x plus 3, I'll keep it the same here. I have x plus 1 here from that. But this one right here, it's just me. Now this time, why am I switching to the denominator? Because it's just me. I love seeing the x in front. So I want to rewrite this here as the opposite, x minus y. But by doing that, I have to make sure I introduce a negative sign here. All right. So really, that's why ultimately I explained earlier, having a negative sign means a negative 1 factor. So that one here, going from here to here, it really means a negative 1 times x minus y. A negative 1 times, you can as associative property, you can bring that negative 1 factor all the way in front, and that's what causes this negative sign. And the same explanation that goes with us. And so in that way right there, now we have a whole bunch of common factors. We got the x minus 2, cancel with that. We got the x minus y, cancel with the other x minus y. The negative sign, people in these days say negative sign cancel with negative sign, but the real truth behind is that when you divide a negative expression by a negative expression, we recognize we purposely made them appear. So dividing a negative expression by a negative expression, we end up with a, so technically we can think of that as canceling the negative sign. We end up with a final simplified expression. Now it's all positive out. Negative divided by negative, it's all positive. The only leftover factor here is x plus 3 in the numerator. And the only leftover factor in the denominator is the x plus 1. And this is our final simplified rational expression from that beginning problem like that.